If tangents PA and PB are drawn from an external point to the circle with center O and they are inclined to each other at an angle of 80 degrees as shown in the given figure, then the measure of angle PO is 40, 50, 60 or 80 degrees. In triangle OAP and in triangle OBP, OA is equal to OB because both are the radii of the circle. OP is common. AP is equal to BP because these are the lengths of the tangents drawn from an external point. That means both the triangles are congruent, which also means that angle POA is equal to POB and angle OPA is equal to angle OPB by CPCT. That means angle OPA is equal to angle OPB and both are equal to half of 80 degrees, so 40 degrees each. Now in triangle OAP, by angle sum property, sum of angles is 180 degrees. Now we know angle OAP is 90, angle APO is 40. So angle POA would be 50 degrees. Hence option B is the correct answer. If the mean of numbers 2, 9, x plus 6, 2x plus 3, 5, 10, 5 is 7, then the value of x is which of the given values? Now mean is given by sum of observations upon number of observations. Mean is 7, number of observations is 7. We get the sum of observations as 40 plus 3x. Solving it, we get x equal to 3. Thus, the correct option is option D. If the volumes of two cubes are in the ratio of 8 is to 125, then the ratio of their surface areas is which of these options? Let V1 and V2 be the volumes of two cubes. Let A1 and A2 be the side lengths of the two cubes. V1 would be equal to A1 cube and V2 would be equal to A2 cube. And we are given that V1 upon V2 is 8 upon 125, which means A1 cube upon A2 cube is 2 cube upon 5 cube, or we can say A1 upon A2 whole cube is equal to 2 by 5 whole cube, which gives us the ratio of A1 and A2 as 2 is to 5. Now, the surface area of the cube would be 6a square. Let S1 and S2 be the surface area of the two cubes. So, their ratio would be 6a square upon 6a2 square, which gives us A1 upon A2 whole square. Now, substituting the value of A1 is to A2 that we got earlier, we get 4 is to 25. Thus, the correct option is option B. Two of the vertices of triangle PQR are P minus 1 comma 5 and Q 5 comma 2. The coordinates of a point which divides PQ in the ratio of 2 is to 1 are which of the given options? Section formula states that if a point S, coordinates being xy, divides the line segment joining points P, coordinates x1 and y1, and the point Q, coordinates being x2 and y2, in the ratio of m is to n, then the coordinates of S are given by x is n times x1 plus m times x2 divided by m plus n, whereas y is n y1 plus m y2 divided by m plus n. Substituting the values, we have x1 equal to minus 1, y1 equal to 5, x2 equal to 5, y2 equal to 2, m2 and n1, we get x equal to 3 and y equal to 3 again. Thus the coordinates are 3, comma 3. The correct option is option C. 2. Then theta by 3 equals which of the given options? We are given that sine 4 theta is root 3 by 2 and we need to find the value of theta upon 3. Now sine 60 is root 3 by 2. That means sine 4 theta is equal to sine 60. So 4 theta is 60 degrees, which gives us theta as 15 degrees. Thus theta by 3 would be 5 degrees. Option D is correct. Zeros of the polynomial py equal to 7y square minus 11 by 3y minus 2 by 3 are which of the given options? Let the polynomial be equal to 0. That means taking 1 by 3 common, we can say 1 by 3 21y square minus 11y minus 2 is equal to 0. Or we can say 21y square minus 11y minus 2 is equal to 0. Now splitting the middle term and factorizing it further, we get two factors, 3y minus 2 and 7y plus 1. Now the product rule says that either of them is 0. Thus, either 3y minus 2 is equal to 0 or 7y plus 1 is equal to 0, which gives us y as 2 by 3 or minus 1 by 7. Thus, option D is correct. A system of two linear equations in two variables is inconsistent if the lines in the graph are which of the given options? Well, a system of two linear equations in two variables is deemed inconsistent when the lines represented in a graph do not intersect at any point. Let's look at our options. Coincident lines mean they overlap completely, which indicates a consistent system. If lines intersect at one point, they represent a consistent system as well because they have a unique solution. Option D is intersecting at right angles still implies intersecting lines and we know that they are consistent. Now let's discuss the option left, which is option B, parallel lines. We know that parallel lines, on the other hand, do not meet at any point. And this is our answer. The system is inconsistent. Do you know how the inconsistent lines are represented algebraically? Comment below and let us know. So our answer is option B, parallel lines. AOBC is a rectangle whose three vertices are 0, 2 is A, 0, 0 is O, and 4, 0 is B. The square of the length of its diagonal is equal to which of the given options? We need to find the square of the length of diagonal of rectangle AOBC. Now, length of diagonal AB is the distance between the points A and B. Now, the distance D between two points is given by the distance formula. D equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Or we can say D squared is equal to x2 minus x1 squared plus y2 minus y1 squared and we need to find D square. Substituting the values of x2, x1, y2 and y1, we get D squared is equal to 4 square plus 2 squared, which gives us 20. Thus, option B is correct. If x is the LCM of 4, 6, and 8, and y is the LCM of 3, 5, and 7, and p is the LCM of x and y, then which of the following is true? Now 4 is 2 raised to the power 2, 6 is 2 raised to the power 1 times 3 raised to the power 1, and 8 is 2 raised to the power 3. Now to find the LCM of these three numbers, what we do? We do take the highest powers of each of the factors and find their product. So the LCM of 4, 6 and 8 would be 2 raised to the power 3 times 3 raised to the power 1. So 24. Similarly, y is 3, 5 and 7. LCM of these three numbers. Now these three numbers are all prime numbers. So the LCM would be the product of these numbers which gives us 105. Now LCM of x and y would be the product of the highest powers of the factors of these two numbers. So it will be 2 raised to the power 3 times 3 raised to the power 1 times 5 raised to the power 1 times 7 raised to the power 1. Now we know that x is 2 raised to the power 3 times 3 raised to the power 1. So we can write it as x times 35, which is the product of 5 and 7. So 35x, which gives us option A as the correct option. A die is thrown once. The probability of getting a number which is not a factor of 36 is which of the given options? We are given that a standard 6-sided die is thrown once. The numbers on the die are 1, 2, 3, 4, 5 and 6. Out of these numbers, 1, 2, 3, 4 and 6, these are factors of 36. So 5 is the only number that is not a factor of 36. Now probability is number of favorable outcomes upon total number of outcomes. Our favorable outcome is that the number should not be a factor of 36 and we have just one such number. And total number of outcomes is 1 to 6. So 6 outcomes. So our probability becomes 1 upon 6. Hence option C is the correct option. See the given figure. In triangle ABC, AD is perpendicular to BC and angle BAC is 90 degrees. We are given that BC is 16 centimeter and DC is 4 centimeter. Then what is the value of x? These are the given options. In triangle ABC, we are given that angle BAC is 90 degrees. So let's apply the Pythagoras theorem. AB square plus AC square would be equal to BC square. Or we can say AB square plus x square is equal to 16 square. We can say AB square is 16 square minus x square. Let's say this is equation 1. Now in triangle ABD, angle ADB is 90 degrees. So applying Pythagoras again, we get AD squared plus BD squared equal to AB squared. Now BD would be 16 minus 4, that is 12 centimeter. So AD square plus 12 square would be equal to 16 square minus x square. We've used the value of AB as 16 square minus x square from equation 1. Thus, AD square is 16 square minus 12 square minus x square. Solving it, we get AD square as 112 minus x square. Let's say this is equation 2. Now in triangle ADC, angle ADC is 90 degrees. Applying Pythagoras again, we get AD squared plus DC squared equal to AC squared. So now AD squared from equation 2 is 112 minus x square and DC squared would be 4 squared. So this would be the sum of these two would be x squared. Solving it, we get x equal to 8. Thus, option C is the correct option. If alpha and beta are the zeros of the polynomial px equal to x square minus ax minus b, then the value of alpha plus alpha beta is equal to which of the given options? To find alpha plus alpha beta, and we are given that alpha and beta are the zeros of the polynomial px equal to x square minus ax minus b. That means sum of roots is a, product of roots is minus b. So sum of these two, sum of roots and product of roots, that means alpha plus alpha beta would be a plus minus b, thus a minus b. Option C is the correct option. Cos theta upon square root of 1 minus cos square theta is equal to which of the given options? Now sin square theta plus cos square theta is 1. That means 1 minus cos square theta is equal to sin square theta, and square root of 1 minus cos square theta is equal to sin theta. That means cos theta upon square root of 1 minus cos square theta is cos theta upon sin theta, which is equal to cot theta. Hence, option A is the correct option. The discriminant of the quadratic equation bx square plus ax plus c equal to 0 and b not equal to 0 is given by which of these options? Now, for an equation ax square plus bx plus c equal to 0, discriminant is given by b square minus 4ac. In our case, the equation is bx square plus ax plus c equal to 0. So, a is b in this case and b is a. So, discriminant would be given by a square minus 4bc. Now, we know that discriminant helps us determine the nature of the roots of an equation. So, can you tell me in the comments below what kind of roots would you get if discriminant is positive? Our correct option is option D. If the midpoint of the line segment joining the points a, 4 and 2, 2b is 2, 6, then the value of a plus b is given by which of these options? Now, this is a line segment, say PQ, and the coordinates of P are a, 4, coordinates of Q are 2, 2b, and the coordinates of the midpoint are 2, 6 as given in the question. Now, let these coordinates be x1 by 1, xy, x2 by 2 respectively. Now, midpoint is given by x1 plus x2 by 2 and y1 plus y2 by 2. So, substituting the values, we get 2 equal to a plus 2 upon 2. Solving it further, we get a equal to 2. Similarly, 6 equal to 4 plus 2b upon 2. Solving it further, we get b equal to 4. Now we need to find the sum of a and b, which would be 2 plus 4, that is 6. Thus, option A is correct. If the area of the sector of circle of radius 36 cm is 54 pi centimeter square, then the length of the corresponding arc of the sector is which amongst the given option? Area of sector is given by pi r square theta upon 360 degrees. We are given that the area of the sector is 54 pi centimeter square and the radius of the circle is 36 centimeter. Using the formula for area, we can express this as 54 pi equal to pi times 36 square times theta upon 360 degrees. This simplifies down to finding the angle theta. By rearranging the equation, we determine that theta equals 15 degrees. Now, with the angle theta in hand, let's find arc length. The formula we'll use is L equal to 2 pi r theta upon 360 degrees, or simplifying it, we get pi r theta upon 180 degrees. Substituting our values, we find that L is equal to pi into 36 into 15 degrees upon 180 degrees, which simplifies to 3 pi centimeter. So, the length of the corresponding arc is 3 pi centimeter, option D. The measurement of triangle LMN and triangle ABC are shown here. The length of side AC would be which of the given options? In triangle LMN, sum of all the angles is 180 degrees. That means angle L would be 22 degrees, which means angle L is equal to angle A, angle M is equal to angle B in triangle LMN and triangle ABC. By AA similarity, both the triangles are similar. Therefore, AB upon LM would be equal to AC upon LN. Substituting the given values, we get AC equal to 8 centimeter. Thus, option C is correct. If in two triangles, triangle DEF and triangle PQR, angle D is equal to angle Q and angle R is equal to angle E, then which of the following is not true? These are the options. We are given that angle D is equal to angle Q and angle R is equal to angle E. That means angle F would be equal to angle P because sum of angles of both the triangles is 180 degrees. So angle D equal to Q, E equal to R and F equal to P. That means triangle DEF is similar to triangle QRP. That means DE upon QR is equal to EF upon RP is equal to DF upon QP. Now let's see the options. Option A is true. Option B is also true. Option C is also true. However, option D is not true. Thus, the correct option is option D. Assertion is if two tangents are drawn to a circle from an external point, then they subtend equal angles at the center of the circle. This is true because the two triangles found by the radii to the points of tangency and the external point are congruent by SSS congruence. Therefore, the angles subtended at the center by the two tangents are equal. Now, the reason. It says a parallelogram circumscribing a circle is a rhombus. Well, yes, a parallelogram circumscribing a circle is a rhombus indeed. This is true. And this can be proved by using the theorem that the lengths of the tangents from an external point are equal. But it is not the correct explanation of the given assertion. Hence, the correct answer is both assertion and reason are true, but reason is not the correct explanation of the assertion. Assertion is a ladder leaning against a wall stands at a horizontal distance of 6 meters from the wall. If the height of the wall up to which the ladder reaches is 8 meters, then the length of the ladder is 10 meters. Reason: the ladder makes an angle of 60 degrees with the ground. Let's first see the assertion. Using Pythagoras theorem, we can find that the length of the ladder is 10 meters. So, the assertion is true. Let's see the reason now. The ladder makes an angle of 60 degrees with the ground. Let the angle that is being made here be theta. So, tan theta would be 8 upon 6, which is about 1.33. Now, tan 60 is root 3, which is 1.73. Therefore, it is false. So, we can say that assertion is true, but reason is false. If the sum of the zeros of the polynomial px equal to p plus 1x square plus 2p plus 3x plus 3p plus 4 is minus 1, then find the value of p. Do you remember that for any quadratic polynomial of the form ax square plus bx plus c, the sum of the zeros can be calculated using the formula minus b upon a. In our case, this is the polynomial. So here we have a equal to p plus 1 and b equal to 2p plus 3. Now according to the problem, the sum of these zeros equals minus 1. We are given that. Thus, we can set up the equation to find p. Minus b upon a would be minus of 2p plus 3 upon p plus 1, and that is equal to minus 1. Does that make sense so far? Let's work through this together and discover the value of p. This gives us p as negative 2. Thus, p is minus 2. Now fancy swapping up p with 2 and uncovering the mystery of px. Dive in and spill the beans in the comments below. If alpha and beta are the zeros of the polynomial px equal to x square minus 2x minus 1, find the values of 1 upon 2 alpha plus 1 upon 2 beta plus 3 alpha beta. When fx is equal to ax square plus bx plus c, its roots are given by this quadratic formula. In our case, px is equal to x square minus 2x minus 1, which gives us a equal to 1, b equal to minus 2 and c equal to minus 1. Substituting the values in the quadratic formula, we get x equal to 1 plus minus root 2, and let's take alpha as 1 plus root 2 and beta as 1 minus root 2. So these are our roots, and we need to find the value of this. Now substituting the values of alpha and beta, and then solving it further, rationalizing it, we get which gives us the value as minus 4. Thus, the value of 1 plus 1 upon 2 alpha plus 1 upon 2 beta plus 3 alpha beta is minus 4. Let's delve into an interesting geometric property involving circles. We want to prove that the tangents drawn at the ends of a diameter of a circle are parallel. Here PQ and RS are the tangents drawn at the ends of diameter AB, and we need to prove that these two are parallel to each other. First, we note that the radii OA and OB are perpendicular to the tangents PQ and RS at points A and B respectively. And why so? Well, this is because the tangent at any point of a circle is perpendicular to the radius through the point of contact, right? This means we have angle PAO and angle OBS both equal to 90 degrees. Similarly, angle RBO and angle OAQ are also 90 degrees each. Now here's the key part. The angles PAO, OBS, RBO and OAQ form pairs of alternate interior angles. Since they are equal, we can conclude that the lines PQ and RS are indeed parallel. Thus, we have successfully shown that the tangents drawn at the ends of a diameter of a circle are parallel. This is a fundamental concept that not only reinforces our understanding of circles, but also the properties of angles and parallel lines. Find the smallest number which is divisible by both 644 and 462. The number divisible by the two numbers is their multiple. The smallest number divisible by two numbers is their least common multiple or LCM. LCM is essentially the smallest number that the two numbers can divide into without leaving a remainder. Now LCM can be found using the prime factorization of the numbers. For 644 we have 2 squared times 7 times 23, and for 462 we have 2 multiplied by 3, 7 and 11. Now when we combine these, we take the highest powers of each prime number involved, which gives us LCM as 2 squared times 3 times 7 times 11 times 23, which equals 21252. So, the smallest number that is divisible by both 644 and 462 is 21252. Two numbers are in the ratio of 4 is to 5 and their HCF is 11. Find the LCM of these numbers. If two numbers are in the ratio A is to B and their HCF is H, then the numbers are AH and BH. Now, in our case, A is to B is 4 is to 5 and HCF is 11. So, the numbers would be 44 and 55. For any two numbers P and Q, LCM of P and Q times HCF of the same numbers is equal to the product of numbers. So, LCM into 11 would be equal to 44 into 55. That means LCM is 220. If 4k is equal to tan square 60 degree minus 2 cosec square 30 degree minus 2 tan square 30 degrees, then find the value of k. We are given this. Now tan 60 is root 3, so tan square 60 would be 3. Cosec 30 is 2, so cosec square 30 would be 4. Tan 30 is 1 by root 3, so tan square 30 would be 1 by 3. Substituting the values, we get 4k equal to 3 minus 2 times 4 minus 2 times 1 by 3. Solving it further, we get 4k as minus 17 upon 3. Thus, k would be minus 17 upon 12. The probability of guessing the correct answer of a certain question is x by 12. If the probability of not guessing the correct answer is 5 by 6, then find the value of x. The sum of probabilities of an event occurring and not occurring equals 1. So x by 12 plus 5 by 6 is 1. On further solving, we get x as 2. Prove that 4 root 2 plus 5 by 3 is an irrational number, given that root 2 is an irrational number. Today, we are diving into a fascinating proof regarding irrational numbers. We start with the premise that root 2 is an irrational number. Now, let's assume for a moment that 4 root 2 plus 5 by 3 is actually a rational number. This is a common approach in proofs by contradiction, where we challenge our initial assumption. If we denote this rational number as a by b, where a and b are co-prime integers and b is not 0, we can rearrange our equation. This leads us to 4 root 2 is a by b minus 5 by 3. From here, we can isolate root 2 and express it as root 2 equal to a by 4b minus 5 by 12. Since we know that both a by 4b and 5 by 12 are rational, it follows that the difference must be rational. This conclusion, however, suggests that root 2 is rational, which directly contradicts our starting point. Thus, we've proven that our assumption was incorrect, and therefore 4 root 2 plus 5 by 3 must indeed be a irrational number. If 65% of the population has black eyes, 25% have brown eyes, and the remaining have blue eyes, what is the probability that a person selected at random has blue eyes, brown, or black eyes? The total percentage of people with black or brown eyes is 90%. The remaining percent have blue eyes, so 10%. The probability of having blue eyes would be 10 upon 100, that is 0.1. And the probability of having brown or black eyes would be 90 upon 100, that is 0.9. A chord of a circle of radius 10 centimeters subtends a right angle at the center of the circle. Find the area of the corresponding minor segment. Use pi as 3.14. Now, area of the minor segment APB would be area of the sector OAPB minus area of the corresponding triangle AOB. Now, area of the sector OAPB would be theta upon 360 degree times pi r square. So, 90 upon 360 times pi r square. So, pi r square upon 4. Area of triangle AOB would be half into base into height. Now, base and height both are equal to the radius. So, r square upon 2. Subtracting 2 from 1, we get area of the minor segment APB equal to pi r square by 4 minus r square upon 2. Taking r square by 4 common and substituting the values of r as 10 and pi as 3.14, we get area of the minor segment as 28.5 centimeters squared. Thus, the area of the corresponding minor segment is 28.5 centimeters squared. In the given figure, PC is a tangent to the circle at C. AOB is the diameter which, when extended, meets the tangent at P. Find angle CBA and angle BCO if angle PCA is 110 degrees. We are given that PC is a tangent, AOB is the diameter, and angle PCA is 110 degrees, and we need to find angle CBA and angle BCO. Now angle OCP is 90 degrees because radius to tangent is perpendicular. Angle PCA is given to be 110 degrees. Therefore, angle OCA would be 20 degrees. Now in triangle OCA, OC would be equal to OA because both are radius. That means angle OCA is equal to angle OAC because angles opposite to equal sides of a triangle are equal. So both are equal to 20 degrees each. Now, angle sum property says the three angles of the triangle OAC is 180 degrees. So, angle COA would be 140 degrees. That means angle COB is 40 degrees because angle COB and angle COA make a linear pair. Now in triangle OCB, OC is equal to OB because both are the radius of the circle. Angle OCB would be equal to angle OBC because angles opposite to equal sides are equal. Now the sum of the three angles of the triangle OBC is 180 degree by angle sum property. Therefore, angle OCB plus angle OBC would be 140 degrees. Now angle OCB is equal to angle OBC, so each would be 70 degrees. Therefore, angle CBA is equal to angle BCO, each equal to 70 degrees. In this question, we need to prove that root of sec a minus 1 upon sec a plus 1 plus root of sec a plus 1 upon sec a minus 1 is equal to 2 cosec a. Let's rationalize the left hand side. We get using the identity tan square a plus 1 is sec square a. So sec square a minus 1 would be tan square a. Solving it further, we get which gives us 2 cosec a, which is equal to the right hand side. We need to prove that 1 upon cos a minus cos a times 1 upon sin a minus sin a is equal to 1 upon tan a plus cot a. Now LHS is this. Taking LCM, we get, so this is equal to sin a times cos a. Now simplifying RHS, we can write tan a as sin a upon cos a and cot a as cos a upon sin a. Taking LCM, we get sin a cos a upon sin square a plus cos square a. Now sin square a plus cos square a is 1. So sin a cos a, which is equal to LHS. The midpoints of the line segment joining the points A and B is P, and x plus y minus 10 is equal to 0. The coordinates of A are 3 and 4, coordinates of B are k and 6, and coordinates of P are x and y. We need to find the value of k. X plus y minus 10 is 0. We are given that. That means x is 10 minus y. Now x would be equal to 3 plus k by 2 because P is the midpoint. That means K is 2x minus 3. Now Y would be 4 plus 6 by 2. That is 5. That means X would be 5 and K would be 7. Thus the value of K is 7. Find the coordinates of the points which divide the line segment joining A and B into 4 equal parts. Let P, Q, and R be the points that divide the line segment joining A, coordinates minus 2 and 2, and B, coordinates 2 and 8, into 4 equal parts. That means AP is equal to PQ is equal to QR and is equal to RB2. That means AP is to PB would be 1 is to 3. Let's say this is M is to N. Now P would be given by mx5 plus nx1 upon m plus n and my5 plus ny1 upon m plus n using the section formula. That means if we substitute the values, we get the coordinates of P as minus 1 and 7 by 2. Now point Q divides the line segment AB into 2 equal parts. Using midpoint formula, we get coordinates of Q as x1 plus x5 by 2 and y1 plus y5 by 2. Substituting the values, we get the coordinates of Q as 0 and 5. Now R is the midpoint of Q and B. So the coordinates would be given by midpoint formula again. Substituting the values, we get the coordinates of R as 1 and 13 by 2. An AP consists of n terms. Nth term is 4 and the common difference is 2. Sum of n terms is minus 14 and we need to find n. Also, we need to find the sum of first 20 terms. Now we know that an is 4, d is 2 and sn is minus 14. Now an is given by a plus n minus 1 times d. Let's substitute the given values. We get a would be 6 minus 2n. Now Sn is given by n by 2 times 2a plus n minus 1 times d. Substituting the values that we are given. Solving it further. Also substituting the value of a from equation 1. We would eventually get a quadratic equation like this. Let's divide this quadratic equation by 2 to simplify it further. Now splitting the middle term. So we get the values of n as 7 and minus 2. But of course n cannot be negative. So discarding minus 2 we get n as 7. Let's find a. So a would be minus 8. Now S20 also we need to find. So substituting the given values, we get a Sn as 220. So the sum of first 20 terms is 220. The sum of first 6 terms of an arithmetic progression is 42. The ratio of the 10th term to the 30th term is 1 is to 3. Calculate the first and the 13th terms of the AP. We are given that S6 is 42, A10 is to A30 is 1 is to 3. We need to find the first term and the 13th term. An is given by a plus n minus 1 times d. Hence, A10 upon A30 would be a plus 9d upon a plus 29d and that is equal to 1 by 3. Cross multiplication, we get, solving further, we get A equal to D. Now Sn is given by n by 2 times 2a plus n minus 1 times d. Substituting n as 6, we get S6 as 6 by 2 times 2a plus 6 minus 1 times d. Thus, 42 is equal to 3 times 2a plus 5d, or we can say 42 is equal to 3 times 2 times d plus 5d. Since a is equal to d, we just found that. So 42 is 3 times 7d. So d is 2. And we know that d is equal to a. So a is also 2. We now need to find A13. So our first term is 2. We need to find A13. It will be given by a plus 12d. Substituting the values, we get A13 as 26. Thus, the first and the 13th terms of the AP are 2 and 26 respectively. A vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Now, volume of cone is 1 by 3 pi r square h. Volume of sphere is 4 by 3 pi r cubed, where r is the radius and h is the height of the cone. Now, lead shots displaced 1/4 volume of water, which means volume of lead shots is equal to 1 by 4 times volume of cone. Let n be the total number of lead shots. So n times 4 by 3 pi r cube would be equal to 1 by 4 times 1 by 3 pi r square h. Now height of the cone is 8 centimeter and radius is 5 centimeter, and radius of the sphere is 0.5 centimeter. We are given that. Substituting the given values and solving further, we get n as 100. Thus, the number of lead shots dropped in the vessel is 100. A man lent a part of his money at 10% per annum and the rest at 15% per annum. His income at the end of the year is rupees 1900. If he had interchanged the rate of interest on the two sums, he would have earned rupee 200 more. Find the amount he lent in both cases. Let the amount lent at 10% be rupee X and the amount lent at 15% be rupee Y. Based on the interest earned, we have these two equations. First, interest earned would be 10 by 100 times x plus 15 by 100 times y, and this is equal to 1900 as given. So we can say 0.10x plus 0.15y is equal to 1900. Now in case 2, interest earned would be 15 by 100x plus 10 by 100y because the rate of interest has been interchanged. Now he is earning rupee 200 more, so the total amount earned would be rupee 2100. So the equation becomes 0.15x plus 0.10y equal to 2100. Now multiplying equation 1 by 150 and equation 2 by 100. Why are we doing this? To make the coefficient of x same in both the cases so that eventually we can subtract the two equations and thus eliminate x. So we get 12.5y equal to 75,000. Thus y is 6,000 rupees. Substituting the value of y in the above equation, we get 15x is equal to 1,50,000 and thus x is equal to 10,000 rupees. Thus, the man lent rupee 10,000 at 10% per annum and rupee 6,000 at 15% per annum. In the given figure, PA, QB, and RC are perpendicular to AC. If PA is X units, QB is Y units, and RC is Z units, prove that 1 by X plus 1 by Z is equal to 1 by Y. In triangle CAB and triangle CBQ, angle PCA is equal to angle QCB, common angles. Angle PAC is equal to angle QBC, each equal to 90 degrees. Therefore, both the triangles are similar. This means QB upon PA is equal to BC upon AC, or we can say Y upon X is equal to BC upon AC. Similarly, in triangle ARC and triangle AQB, angle RAC is equal to angle QAB, common angles. Angle RCA is equal to angle QBA, each equal to 90 degree. Therefore, both the triangles are similar, and thus QB upon RC is equal to AB upon AC, or we can say Y upon Z is equal to AB upon AC. Now, adding equation 1 and 2, we get so 1 upon X plus 1 by Z is equal to 1 upon Y, as we needed to prove. Sides AB and BC and median AD of triangle ABC are respectively proportional to sides PQ and QR and median PM of a triangle PQR. Show that triangle ABC is similar to triangle PQR. In triangle ABC and triangle PQR, AB upon PQ is equal to BC upon QR is also equal to AD upon PM. This is given. BD upon QM is BC upon 2 upon QR upon 2, that is equal to BC upon QR, because AD and PM are medians. Now in triangle ABD and triangle PQM, AB upon PQ is equal to BD upon QM is also equal to AD upon PM. That means triangle ABD is similar to triangle PQM. That means angle ABC is equal to angle PQR. Now, in triangle ABC and triangle PQR, AB upon PQ is equal to BC upon QR. We are given that, and we just proved that angle ABC is equal to angle PQR. Thus, triangle ABC is similar to triangle PQR. The Indian Meteorological Department observes seasonal and annual rainfall every year in different subdivisions of our country. It helps them to compare and analyze the results. Based on the information given here, answer the following questions. Write the modal class. Well, modal class is the class with the highest frequency. So it would be 600 to 800. Next is find the median of the given data. For finding the median, we first need the cumulative frequency of the given data. We found out that sum of frequencies is 24. So, n by 2 would be 12. Now, 12 would lie in the class 600 to 800. Hence, median class is 600 to 800. Now, median is given by sum of n by 2 minus Cf upon f times h and L, where L is the lower boundary of the median class, so it will be 600. N is total number of divisions, which is 24. Cf is the cumulative frequency of the class before the median class, so it will be 6. F is the frequency of the median class, 7. H is class width, so 200. And median would be 771.43 millimeter. Thus, the median of the given data is 771.43 millimeter. The or part of the same question is find the mean rainfall in the season. The table here shows that sigma Fixi is 20,400, sigma Fi is 24, mean is given by sigma Fixi upon sigma Fi, so mean is 850. Hence, the mean rainfall is 850 millimeter. Last part is, if a subdivision having at least 800 millimeter rainfall during monsoon season is considered a good rainfall subdivision, then how many subdivisions had good rainfall? Well, such subdivisions would be the ones that received rainfall equal to 800 millimeter or above it. So total number would be the sum of frequencies, which is 11. A garden designer is planning a rectangular lawn that is to be surrounded by a uniform walkway. The total area of the lawn and the walkway is 360 square meters. The width of the walkway is same on all sides. The dimensions of the lawn itself are 12 meters by 10 meters. Based on this information, answer the following questions. Formulate the quadratic equation representing the total area of the lawn and the walkway, taking width of walkway as x meters. Now this is given. Total dimensions of the lawn plus the walkway will be 12 plus 2x times 10 plus 2x. Total area of the lawn and walkway can be expressed as 12 plus 2x times 10 plus 2x equal to 360. Now solve the quadratic equation to find the width of the walkway x. Let's expand the equation for total area. We get solving this and then dividing the equation by 4, we get, let's split the middle term, we'll get x as 4 because we can discard the negative value. Thus, the width of the walkway x is 4 meters. Next part is, if the cost of paving the walkway at the rate of rupee 50 per square meter is rupee 12,000, calculate the area of the walkway. Let the area be A. So A times 50 would be 12,000, which gives us A as 240 meters square. Thus, the area of the walkway is 240 square meter. Find the width, find the perimeter of the lawn. Now, perimeter is given by 2 times length plus breadth. Substituting the values, we get perimeter as 44 meters. A lighthouse stands tall on a cliff by the sea, watching over ships that pass by. One day, a ship is seen approaching the shore, and from the top of the lighthouse, the angles of depression of the ship are observed to be 30 degrees and 45 degrees as it moves from point P to point Q. The height of the lighthouse is 50 meters. Find the distance of the ship from the base of the lighthouse when it is at point Q, where the angle of depression is 45 degrees. Now in triangle BAQ, tan 45 would be BA upon AQ. So 1 would be equal to 50 upon AQ. AQ would be 50 meters. The distance of the ship from the base of the lighthouse when it is at a point Q is 50 meters. Now find the measures of angle PBA and QBA. This is angle PBA and this is angle QBA. Angle ABC is 90 degrees. So angle PBA would be 90 minus 30, that is 60 degrees. Similarly, angle QBA would be equal to 90 minus 45, that is 45 degrees. Now, find the distance traveled by the ship between points P and Q.
Let the distance between point P and Q be x meters. Now in triangle BAP, tan 30 is BA upon AP. So 1 upon root 3 is 50 upon 50 plus x. Solving it, we get the value of x as 50 times root 3 minus 1. So x is around 36.6 meters. So the distance between the points is 36.6 meters. If the ship continues moving towards the shore and takes 10 minutes to travel from Q to A, calculate the speed of the ship in kilometer per hour from Q to A. Now AQ is 50 meters, so 50 upon 1000 kilometers. We are given that time is 10 minutes, so it will be 1 upon 6 hours. Distance is speed into time. So speed would be distance over time. So 50 upon 1000 is the distance and the time is 1 by 6. So it becomes speed equal to 50 into 6 upon 1000, that is 0.3 kilometers per hour. So the speed of the ship is 0.3 kilometers per hour.